Okay, I'm back over here at the welding table with the carbon fiber mold for the intake on the 83 Cummins. What are some of the things that I've got to do is I've got to figure out how I've got to lend thought to the process of laying this carbon fiber up onto the mold as I'm building it up. And what I'm going to do is show you some of the thoughts that I have. I've got to find another area in the shop to actually work on this, not on the welding table. So let me shut you off, and I'm going to bring you back in and show you what I'm talking about the issues that could be involved in laying it up. The other thing that I've got to do is extend this where the silicone boot is going to go onto it. Not only do I have to extend it out, but I've also got to create an area that will hold the clamp. So if let's say if you were looking at the boot, what I've got to do is create a couple of raised ribs, so when the silicone boot goes up over it, the clamp can clamp it down and hold it in between a couple of ribs. So on this mold, some of the things that I've got to think about is how I am going to lay the fabric underneath this and lay the flange area into it when I've got such a tight space. So what I might have to do is build it up a little bit more, so that I have room to work under here. Now, kind of what my thought process is on this originally is maybe I will take this piece separately and put the first layer of carbon fiber, or maybe even 2 layers of carbon fiber on it beforehand, and then attach it to this and build the flange and mold the carbon fiber that's going to come up and be incorporated into the majority or the large piece of the mold from the flange secondly. But I need space back in here where I can work on it so that I can get it in there. So that's kind of where I am right now. So what I'm going to put another layer of this onto it, just so that I have more room to work around it. Okay, I'm over here to the portable table where we had been rebuilding that G56 transmission out of the Ram. But since that project is done, I've got this table back and I can use it for that intake manifold. Now, I had to go get a couple of tires today, and the only reason I'm telling you that is because it gave me time while I was sitting in the waiting room to do a little research back into carbon fiber material and Kevlar. Okay, let me interrupt you just a second here. For you that are new to the channel or first-time viewers or don't remember what I'm talking about, the Kevlar and carbon fiber, I'm going to put a link up there to my last video where I discussed whether carbon fiber by itself would be strong enough to withstand both of engine vibration, heat, and pressure that is going to be created by the turbocharger on this. So I was talking about using Kevlar as well as carbon fiber. So I'm going to bring you back right to where I left off. What I found is a couple of companies that sell a composite material. Has both carbon fiber and Kevlar weave in the same material. So I'm going to be looking into that option, and instead of having to build ribs out of Kevlar across that to keep it, it's very possible that that composite material will be strong enough to, or I think it will be strong enough to support the vibration loads and the pressure load that's going to be on this intake manifold from the turbocharger. So again, I've got to do more research, but I kind of thought I'd kill two birds with one stone, show you that I was back over here at this table to be able to continue work on it, and just kind of apprise you of something that I found on the internet today, where they have that composite material, which is carbon fiber and Kevlar in the same weave. So I'll bring you back. So I'm back doing a little more work onto the intake manifold, and one of the things I told you that I was going to cut another piece of foam to add it down to here to bring this height up farther so that I could lay the fabric in here when I lay it onto the mold. When I build the fabric up around the mold, I want to be able to have room in there so that I can lay it in properly and squeegee it out properly to get good coverage with the resin and without getting air pockets. But one of the things that I did is I just came over here, and you can see that my mold has, I don't remember it being this small as in relationship to the opening. It may have shrunk some. I'm not really sure, to tell you the truth, but it's not bigger. So it's not, doesn't cover the full area. I shouldn't say it's not bigger. What I've done is cut this other piece to cover that full area. And that will give me two things. Maybe in the process, I will be able to reshape this. Let me bring you back to that. One of the reasons that I said it has shrunk things, I'm getting cracks in here that weren't in here before. And I have a feeling that foam is shrinking underneath where I have put skim coats of body filler and stuff like that, causing them cracks in there. But anyways, I'm bringing this piece that I'm out here cutting to add on to it so that it's the full size of this opening. And then maybe I can shape this a little better to get a smoother flow down into there. What I'd like to do, be able to do, is get a flow that is more uniform and jetting out to these areas that are not covered by the intake manifold, so that I can get an airflow to go into those tucked behind areas that way, so that the airflow transitioning out of this intake manifold will flow more uniformly into those concealed spaces, let's put it. So, which means that I might be able to bring this down at a better angle, or an angle that's more inducive of getting that airflow back in there. But anyways, I'll bring you back. I just thought I'd share that with you. I brought you back over here to the head, and just for kind of a brief explanation, I kind of explained in the last video about this head. This is number 1 and 2 cylinders, and the air intake for number 1 and 2 cylinders, more so for number 1 than it is for number 2, but even for number 2, the air port or the intake port is back in here. So it's covered. So what I was kind of talking about is getting having that airflow go into there kind of in a forced method by having this thing tapered down. Now, for what I'm using this engine for, haul truck, this will be fine. If I was building a performance engine, and the reason why you want to get more air into there, better airflow into those cylinders, is because it reduces the exhaust gas temperatures. It has more air going into it. Sometimes, like on the Cummins 5.9 or 6.7, it's the 5 and 6 cylinder that are starved for air, and if you put it under load for periods of time or load for over and over again, you will have number 5 and 6, more likely 6, go out before the other cylinders because of that excessive heat that's built up because of the lack of airflow into the engine or into those cylinders. So if I was building this for like a drag thing or a pulling truck or tractor, I would put more of a taper into these things so that you get more of a linear flow, a smoother flow back into those kind of, let's call them buried intake runners in the manifold or in the head of the 8.3. And again, the same thing happens on the 6.7 and 5.9. Now, what they do, though, is if you're doing a modified pulling truck, they will chop this intake manifold off totally and build a new intake manifold that has ports going directly into it, so that the intake manifold would be the entire length of the head, with the air being fed into the intakes runners right directly from that intake manifold. Since I cut it a little bit oversized, what I've done is put lines on the bottom of this representing from the line of the bottom of it where I want to take it back into the mold, my existing mold. So I work from that line and form it back into the mold in those cases. So there's a line on the back. I'm just going to do it from this outer edge to the mold surface on there, and yeah, go from there. So what I did is I put it on there, and I kind of formed it a little bit to get to basically that shape that I was looking for, and mixed up a little bit of body filler, and I kind of filled in some of the little voids on it. I don't want to mix up or put it on too heavy because that body filler heats up, and what it does is it'll shrink that foam on that heat from the body filler. So I've got to do it in stages, light stages. But I'll bring it back. Okay, so I'm over here to the mold, and as you can see, I have put the other layer on, so raising that area up so that I can lay in that carbon fiber or composite fiber, which is Kevlar and carbon fiber, more easily and be able to get to it to kind of squeegee it out and lay it in there properly. One of the things that I had mentioned before was the flow characteristics of that head, and let me take you back over to that head, and I'm just going to expand upon something a little bit. I'm not going to show you a lot of this because a lot of this is just like filling in areas with body filler and stuff like that, and it's pretty boring and irrelevant. What is relevant is the end product and how uniform it is. Now, when I say uniform, I'm talking about the inside of it. Yeah, I care about what the outside looks like, but I'm more concerned with the flow characteristics of the inside of this thing. So let me take you over to the head, and I'm going to expand upon that a little bit. In a previous clip, I had talked about, and I've got a light here, so excuse it if it isn't right. It's just clipped to me. So I will put it inside of here to show you what my point is going to be in a minute. But let me expand upon this outside of it. As you can see, the runners going into the intake port are all curved surfaces. And it's good for this area, the way it's curved in, and back here it's kind of that way too. But once you get over in there, you're going against the flow. And when I say going against the flow, let me show you what I mean. So we have the runner that goes into the intake port, and as you can see, it's curved back that way. So when you get to this thing, where number 1 and 2 cylinders are kind of buried back there, the flow goes in and comes back this way. So I'm not an engineer, but I do know some things about flow dynamics. I was in the fire protection business for 47 years, and flow dynamics of water is extremely important in fire protection. Getting water to nozzles or fire protection heads, sprinkler heads, whatever, is very important. And one of the things that is very important about it is velocity. The velocity of a flow of a fluid or of air, which is dynamically kind of the same as fluid. There is differences, but basic dynamics is kind of the same. Flow characteristics are kind of the same. Is very important. In the fire protection industry, we had a velocity that we could not exceed of water flowing, because exceeding that velocity would cause the flow to maybe overshoot one of the outlets. In other words, if the flow was going this way and there was a T here feeding a fire protection nozzle or a sprinkler head, and you had heads that were going off down here, if the water velocity became too much, it would kind of bypass maybe this open head, because it was going to the path of least resistance of open heads back here. So the velocity in heads or velocity of the stream can be very important. And that's kind of why I wanted to cater this back in here where these heads are, where these, the intake ports are buried back there. The same way with the one cylinder, number 6 cylinder back there. But anyways, so that kind of, I just wanted to kind of expand upon that port, or on that point, because I kind of want to make sure that I get excess airflow back in there where it could be needed, where it's restricted and the flow is counterintuitive to the way the flow of the air is going back in there. In other words, it goes back in there and then has to make a turn back in. So I just wanted to expand upon that point. I'm just going to make one more point here and clarify something else too. The other thing that's important in this thing is the flow characteristics being smooth and even and having an even flow characteristic of it. By putting things like these bumps in here, now these bumps are needed because that's where the bolt goes down through to hold the intake manifold, but you see how well they have rounded them. But it still will cause an eddy or a turbulent in the flow characteristic. Now, it might not be as important with this engine because I'm not using this engine for racing. The engine is going to be used basically with the normal engine RPM. If I was doing this for like a pulling tractor or something like that, where the RPMs would be probably doubled from the normal, maybe even more than doubled, then it becomes a problem because you're needing more air. The same way with that thing that I was talking about, the velocity of the air going past it, not a big deal in an engine like this for two reasons. Because the RPMs are down, but also because of the firing order. So this engine is 153426, I think it is, the firing order. So you don't have adjoining cylinders firing at the same time where you could have like number 1 firing and then number 2, which could create a starvation of air there. That's not the case. It's 1, 5, 3, 4, 2, 6. So you've got kind of staggered firing orders or staggered areas where the air is going to be consumed. But you still need to keep that in mind. More important if you were building this thing for a race vehicle or anything like that where the RPMs are going to increase. But I just thought I'd point that out. But that's probably going to be it for this chapter of the carbon fiber build. But I'll bring you back.